Latvian, you say labdien. So I'm happy to see you here. I hope you feel good. I'm here also to make you feel better. I even have prepared some physical activities with your gadgets, if you have some in pocket. So either iPhone, Android device, maybe from Windows Phone or tablet. So if you have them, you can take them somewhere out already. One of the previous speakers, Lorenzo, said he's evangelist. My father is evangelist. I'm just a load balancer yet. So I'm balancing with one leg in academic field, with another leg in commercial networking. I'm in University of Latvia. This is my last year for PhD. I'm also participating in some research projects and also for European Commission and European Union. And also in some research projects which are a bit related with commercial networking. Then when I say I'm also with a second leg in commercial networking, I work with ISPs. Usually my field of interest is combining MikroTik devices with existing Cisco networks, helping to improve them. So that's my specialty. So today, I'm going to walk you through fast IPSec configuration. So the target audience is medium experienced users. I will have also some emphasis for professionals. But I would like to start with a small explanation about the domain and the topic where we go in. So what's IPSec? I usually like to tell that IPSec is a marketing name. Why? Because it consists of a lot of ingredients. Yes, it is one of the VPNs. Also, the VPN is marketing name in my opinion. And there are also others in RouterOS, like SSTP, OpenVPN, PPTP, L2TP. But today we speak about IPSec because this one is the most complicated one and also the most secure one. Let's look on Sandbox. So it's a very, it's a framework of typical scenarios, what you can get in IPSec. You can imagine, sometimes you call it road warrior, sometimes it's a remote user, sometimes it's someone working from home. We even had some requests. I think one of my American colleagues told about employee working from jail. So a very specific type of VPN is necessary to support such connection. So usually it looks like that. There is a station, a mobile station or a tablet which over the public cloud has to access some private networks. You can imagine that at the remote side, after your router, there is either a CCTV camera, as you see, or web server, maybe a file server, or your own private cloud, where you store your music, photos, videos, and so on. Also, you can imagine, maybe in Italy, it's also very important, a coffee machine to which you can connect, order something, and when you arrive, it's done. Or maybe for some guests who are there. So a lot of applications, and the VPN, first of all, helps you to bring those commands, requests, files over the public cloud to the right router. And the second thing, to protect that others cannot now print on your coffee machine, so that's only for you. And also that others cannot see the data you send over the network. They cannot modify it. They cannot steal the data. They cannot steal credentials from your data. And it's secure. So today we will focus on fast configuration. When I was wondering about the topic, you can understand it in two ways. So first way, how to make configuration in small amount of time. So you do it fast. A second approach will be how to make a configuration which works fast. So I will try to address both of these vectors here in my presentation. And here is also a small challenge. The previous speaker, Jānis Meģis, agreed that the one who can configure his mobile device and a brand new router which is brought out from the box, so one kind of IPSec tunnels within less than 5 seconds, Italian pizza from Yanis Medis. So first one who can show it will have a present there. So I have also just did some small timings here just to have a clue how much it would take, because where's the problem with IPSec if you compare with others? Maybe you have counted there are around 65 different fields you have to configure in IPSec. And as these fields are so many, there is a large possibility for you to make the mistake, because the sense is in combination of several fields. So if you know exactly which fields, what values have to be there, it's easy. But if you start now experimenting and one field went wrong, then all next year tries also go wrong. Maybe you have tried to put together the Rubik's Cube. Now the scientists have proved that within less than 12 moves, you can solve it from any position. So here with the IPSec, if you want to solve it from any position, the best approach is clear the configuration and start from the scratch with the right one. It's the fastest approach here. So let's look on possibilities, what some operating systems has to offer. First of all, I would like to focus on RouterOS. This is the latest stable version. I have divided here authentication methods and also exchange modes. So those in bold are most common for mobile networks. The signature means instead of pre-shared password, we use a certificate chain. It's a private public key pair, so asynchronous encryption. About that we will go a bit deeper later, but these two are those most in common. For exchange modes, if we speak about mobile network, we have IKE2. It's a very fresh and modern feature here in RouterOS, and also L2TP authentication. That is for a longer time, and we will look on both of them in our presentation today. There's also IKE1, or the main mode, which is very popular in fixed IP configurations. Unfortunately, with the mobile configurations, there is a challenge that you never know from which IP address your customers or workers or clients will connect in. So that's why it's a challenge for the main mode. So if we look now on iPhone, so it's iOS running the latest 10.2.1, only 3 approaches left. They say IKE2. This one is the same as IKE2 in MikroTik. And also you see here is in the scopes EAP, it's Extensible Authentication Protocol. So IKE2 has 2 modes, either with pure authentication, which can be both password and certificate, or EAP. At the moment, MikroTik started just in the latest release candidates to support EAP over the Radius server. So that's also included. Now, if we move the second choice, what iPhone offers, it's said IPSec. Actually, it's IPSec together with X authentication. X means extended authentication, and you have to configure also mode configurations. Then the third thing, which is the easiest to implement, it's L2TP over IPSec, but it has some drawbacks about which I will speak a bit later. Regarding Android, it's one of the latest versions. There is also Android 7, but this is from Android 6. Android 6 still has PPTP. I think the 7 doesn't have it anymore. So here they have, I would say, better described the VPN technologies from which you can choose from. So once again, IKE2 is the choice about which you have to think of a primary choice. Still some issues now, but they, I think, will be okay in the near future. And L2TP IPSec, which is the first in the list, as the second choice for the mobile workers. X authentication also is an opportunity, but if you look on the fast implementation, then not this time. On the left here you see a small explanation what is pre-shared key. So that's a password. It's not a password which is used for encryption. You can think of this password as the code card for internet bank. So maybe you have seen the technology where the internet bank is asking one time one of the codes, another time a different code. So this password just serves as a domain from which to take characters under mathematical computations. RSA approach, these are 3 scientists who came up with this approach in last century. Now these key sizes have grown. So here we speak about asymmetric encryption. What's asymmetric encryption? This is when you have 2 keys, and now depending on the application, in the tunnel encryption is like that. With your with the remote private certificate, you encrypt, and with a private key you can decrypt. So one key is for encryption, another key is for decryption. If you encrypt with one key with the same key, you cannot open it anymore. In digital certificates, which you have in national ID cards, for example, it's opposite. Then with another key you encrypt and another decrypt. So this one has to have 2 keys to be able to encrypt and decrypt the traffic. For those who are afraid that someone can steal your data, and actually there is such situations when users think, okay, we go with the latest IPSec, everything is very secure, and after some time, a secret service shows them what they did over the channel. So usually the problem is in the key itself. If you record or capture packets at the moment which are encrypted, and later if you manage to get the keys from which actually the real encryption keys were calculated, then you have much easier possibilities to decrypt what was encrypted yesterday. So the clue here is, if you want that tomorrow no one can hear your VoIP call from today, change your key this evening. So that's the point here. Now, if we look on Windows 10, it has a wider choice list. So IKE2 is also here, L2TP is also here, even PPTP is here. For ages, PPTP was the primary choice because it was the easiest to implement. And unfortunately, often you have to choose easy to implement, secure to use. And so you have to stand somewhere in this choice, either for easiness or for security. So here the PPTP was the easiest on all the applications, but unfortunately it was not that secure, and that's why some vendors do not support it anymore. So here is a matrix where we can see pros and cons for each of them. So L2TP, from the fast configuration perspective, actually is the first choice where to look, but it has 2 significant drawbacks. One thing is overhead, because our packet is twice encapsulated. Later I'll show how it looks. The second problem in the protocol is that if there is a user who is sharing the public address with another user, so it means they are behind the same NAT, the remote side cannot distinguish the packets from which user they come, so only one of them can work with. In our first experiment here, we will also try to deal with L2TP IPSec configurations. And for those who have some other internet connections than just our regular connection here in the Wi-Fi, they will have some better opportunities to get to the result. For others, you will feel how it is for 1,000 persons to share the same public IP address when you go with L2TP IPSec connections. The rising star IKE2 It's much better in signaling, also has native support to deal with the NATs, but yet it's still very fresh technology. So still some stability issues and also much more complicated certificate configuration. If we have time, we will try this one also. So let's jump in the first one, L2TP IPSec. This is how the configuration looks in iPhone. So the main fields, okay, description, that's for yourself. So you know it's your tunnel going to Riga. The server, it can be either IP or DNS name. So this is the field which has to be configured on the client side. Then account, it's a L2TP username. Then comes a password, it's L2TP password, and finally a secret. So sometimes it's a bit misleading. What's the password? What's the secret? So password is for L2TP, secret is for IPSec. So these fields have to be filled in correctly in your mobile devices. So now if you calculate, if I have 1, 2, 3, 4, 5 fields, if the second is for each field, then to accomplish a task and to do the whole setup in 5 seconds, it's already too late because the other side also has to be configured. So you have to come up with a quicker method then. What's brilliant here is the switcher here to choose either you are willing to route all the traffic over the VPN or no. If you say to route all the traffic over VPN, then you can hide your activities if you are in public place, for example, doing Wi-Fi, checking your mails, who can be stronger or less stronger encrypted. So if you are like in untrusted network location, you could just open the VPN and connect wherever necessary, using this send all traffic and routing it over. Otherwise, if you need to access just specific resources, for example, in Singapore with a high latency, then possibly you are not very interested to route now all the traffic through the Singapore, what you do now here. So it's your choice. Usually it's on, but it's a possibility to switch it off. Also for remote configurations, if you have an access list or a whitelist in your firewall, so it's input chain there, and you have specified multiple addresses from where you can connect to your router. Security-wise, it's also risky because anyone who has access and is in the middle between you and your router could come up with the same IP address and open the same connection. So now, if I'm standing here and my router is in Riga, Latvia, and I connect there, and in a whitelist I have opened my dedicated IP address here, all transit operators can also do the same while in the transit. So they are just in the middle, they can both send there and receive back the packet. So if you want to go more secure, then manage your routers over VPN. So first of all, you do VPN authentication and then just log in your router. So now this was the first side of implementing fast IPSec tunnel, so configuring client. These fields you can start already preparing. Soon you will have an opportunity to try to put something in and see how much time it takes. We'll have an example what to write in these fields. But so far, that's about client. Now about RouterOS. MikroTik has made it a bit easy to enable almost everything that is necessary just with one click. So here, I think you could guess even where the click has to be done. So that's the checkbox in QuickSet to enable VPN access. Additionally, it's advised to have some VPN password. This password will go as the password for all PPP tunnels and also as IPSec secret. So security-wise, maybe you want later to change to have different passwords, but from fast configuration perspective, actually that's acceptable if you choose a secure password, which you can type in quickly, not to damage your implementation time, and later can remember for mobile devices, that's it. So a checkbox here. What are results after this checkbox? So these lines in configuration are generated. First of all, QuickSet is creating a new pool. Maybe you have used somewhere already in default configurations to subnet 192.168.88. So that's very popular for local networks. Then here comes the next subnet. If you see somewhere, you can think of Quickset made VPN configuration. It's subnet 192.168.89, which is generated. Then L2TP server is enabled with IPSec secret, which matches what you did in the previous step. Also, PPTP and SSTP servers are enabled with the same password and a new profile which will take IP addresses from this pool. Finally, a masquerade rule is made, and the traffic will be also masqueraded. So you could ask what else is necessary for such setup, and now we have millions of different scenarios where we could go, but the most popular questions could be, what about firewall? So either firewall allows us to connect to VPN services or no. This is one thing. What about fast track? As the previous speaker, Yanis, said, be careful in the fast track together with some services which has to be served on each packet level, not just some packets belonging to the connection. Then what about other VPNs who maybe are in the router already, or different types of the VPN clients with different requirements who need to connect simultaneously. But if you start with just fresh, empty router, actually it's a very good approach. So here is what I would like you to configure at the client side. And we work so with L2TP IPSec clients. You can now bring up your device if you are ready to move a bit your fingers around. So some physical activities for IT guys. Why to move all the body is just fine to move the fingers and brain. So here, description. Actually, this is anything you like you can put in. I put Riga as the tunnel will be made over the Europe to the Riga. The server, it has to be vpn.t.lv. It's a domain which resolves to the VPN server at that side. It's not ready yet. We will configure it together. Account, by default, Quickset says it's VPN. And both passwords will be mum small letters. And the default setting to send all traffic over the VPN, it's still here. So what you need to remember is Riga, the server name, and account is VPN, and both passwords mum. So actually, 1, 2, 3, 4 different values for now to remember for the configuration. The expected result is that, first of all, you will see that you have connected. And then some of you will be lucky, for those who have come from unique IP addresses, while opening any HTTP website, to see this actor doing tricks in your web browser. So this actor is located in private network. You can access it only after successful creation of VPN. So that's from the client side. From the server side, now I will switch to the router there, so you can see and follow me. Hopefully the resolution is fine enough. So it's just a fresh router with the exception that there is a password set. So you didn't have to hack it. Otherwise, everything else is just with no configuration. You can even see some volunteers. The uptime of the router is just 24 minutes. So you see how many volunteers try to get in and also, but they don't understand that we do L2TP, not the SSH lesson here. So if I do Quickset, here is this button for VPN access. At the moment, I have no IP address on my LAN interface. It shows up as the red. To make it happy, I will make one. Let it be. So IP address, and I select some subnet. If I had some LAN address, it wouldn't be so angry on me. And I say VPN access, and you see, it showed me some additional fields. So here is the username, which we will use as the username for your setup. And the password was small letters mum. So I do OK. And in this moment, everything at the router necessary to accept your L2TP IPsec connections is done. If I do just export of my configuration, here is what's generated. If you go now, IP and IPsec, you see there is a dynamic peer which accepts connections who can show the secret mom. The exchange mode now is main L2TP. In the addresses, the lifetime is 1 day, and from encryption, we support SHA-1 and some encryption algorithms. About these parameters, we will discuss a bit later, but for now, just to understand that all necessary templates are here. Also, for policies, it's made, and you can see at the moment we have already 10 who have established the connection. And I just need to add a small NAT rule for you to intercept your HTTP traffic and move it to the web server. So it's just a destination NAT chain. I want to grab all TCP/AT packets and action destination NAT to the web server. So for those who have now successfully connected, if you open the web browser, you should see the actor unless you are coming from, if you are coming from unique IP address. At the moment, we have already 11 connected. Later, we will speak about troubleshooting, but what you want to see is here, first of all, that there are dynamically generated policies, and you can see from which source addresses they are coming, and that there is established state for phase 2. In IPsec, there are 2 phases. If you fail on phase 1, you cannot succeed with phase 2. But in order to work with IPsec, phase 2 is necessary, otherwise nothing is working. For phase 1, you can go to remote peers. As you see, around 40 now participants have already at least registered in phase 1, but the problem is that the largest part of them come with the same remote address. So sorry for those who have this public IP address. Now you feel how it is when multiple users are behind the NAT. So we have such 20 at the moment, a bit more. If we look now on some of individual ones, you see the state is established. So for phase 1, it's written here remote peers without any additional notice about the phase 1, but that's the phase 1. So you want to see here established status. If you don't have established here, you continue working on phase 1, not phase 2. So this is now up for 3 minutes. The second step where to go, this is installed security associations. We have 76, 2 per each tunnel, so we have 2 directions, the transmit and receive directions. And here, actually, if you unhide the passwords, are real encryption keys. So as the password, we just put in the mom. It was our IPsec secret. From this mom, for different sessions, the system generated, and now you can see what are actual encryption keys. So if someone now copies this encryption key and also captures your traffic to Riga, Latvia, they can easily decrypt your session. This key is changed depending on your timing here. So default timing here is 30 minutes. So now if you have a key for half an hour, you can capture and decrypt everything that is in on the wire. And as you notice, for each connection, we have a different key. So that's the result of the phase 2. Let me see. The NAT rule has captured 153 tries to go to some web server. Possibly also a NAT rule was necessary, but the general one actually covers everything. Also, what we have to mention that the pool contains only 253 addresses. So if you come late, then for all our crowd here, even if you had unique remote addresses within this pool, you wouldn't fit. So it means I would need to extend the pool here, then you can go wider. Actually, there is a workaround if you want to keep it easy. if you want to keep it easy, but still be able to connect there over L2TP IPSec to the server if your users are behind the NAT. The answer is to have multiple public addresses at the server side. So then for each of your clients or customers or workers, you could configure a different IP address and then place multiple external addresses on your router. This is a workaround how to go over this, this problem here. So for now, we just go back to the presentation. If we have time, we will have another activity with IKE2. It's a more difficult one. So now, back to presentation. So how many of you saw the actor in your smartphones? Can I see some hands? Some hands rising, yeah. So the L2TP IPSec part is successfully accomplished in the first task. Let's look a bit now, it's more for engineers, what happened with our packet and why it was a problem also for others to access the actor web server. So let's assume it's a ping packet or web packet going from your device somewhere. First of all, within this technology, it's encapsulated in L2TP frame. So we have a new source address, a new destination address, also new source and destination ports. In our situation, as we did it, it's not yet encrypted, but it's encapsulated so that L2TP can provide IP addresses. This is just for routing purposes. Now, when IPSec comes in, it encrypts everything that was inside. So L2TP already added an overhead around 50 bytes. Comes IPSec, which now encrypts it and then sends to the IPSec server. If it's going through the NAT, usually the destination port is 4500. The problem in the remote side is that when we have multiple connections coming from the same IP address, we cannot glue together L2TP connections with IPSec connections. When we decrypt IPSec connection, then connection tracking will see a new L2TP connection. But it's not possible for them to glue them together. That's why the problem arises here. So if we go next and a bit deeper, speak of some cryptographical elements. So what usually we want to achieve when we go over cloud, first of all, authentication, that no one else who doesn't know the passwords cannot access our resources, for example, the CCTV or video camera back home. Then access control, that we have some addresses, and on the firewall level, we can limit something, confidentiality, that no one can see what we see over this VPN, so it's a good encryption, and also data integrity, that someone didn't change something in the past, even in encrypted way. The core of it is usually two elements. If we don't speak about hashing, then one thing for encryption is the type and power of algorithm what you use. Another thing is key. So here the security is as strong as your weakest link. Either the key is weak or the algorithm is weak, or both of them are weak. It can be compromised easily. So now, which algorithms are preferred? Advanced encryption standard IS algorithms is your primary choice. It's also possible to use them for SSTP if you do it between RouterOS devices. All others are not for you anymore. Then we can look on the key sizes, and here are two types of keys and encryption. Symmetric, this is what happens on phase 2 in IPsec tunnels, and asymmetric, phase 1. So for symmetric, they require less resources, and usually we have smaller keys. So 256 is a very good key for demanding requirements as we have today. For asymmetric, it was around 1024 bits earlier. And now 2048 already is considered for the standard demands, and 4096 for highly protected applications. MikroTik router supports even higher ones, but then it also has a significant load on your CPU. So if you are not really fighting with someone, then that's not for you. Here's an example. If we wanted to encrypt MikroTik MAM Milan 2017, and the key is Italian figurati, then in base 64, you can see here 3 answers. The first one is AS 128 bits. The second one is 192 bits. Interesting, it's shorter, it looks shorter. And the last one is AS 256. So when we speak about overheads, also the key size influences what's the overhead of IPSec. So there are some well-known overhead fields which are always there, but there's also the varying size. When you encrypt the data, so the payload, it also grows. A few words also about firewall requirements. As I said, the quickset did nothing with the firewall. So if in the firewall you were discarding either any new packets or any unknown packets, this VPN implementation wouldn't work. Here are 2 things what's necessary. So for phase 1, UDP ports 500 and 4500, you could change them, at least 500 in IKE parts, so it's phase 1. And for phase 2, this is protocol 50 with some optional extensions when you don't encrypt data but just do headers. It's protocol 51. Be careful of fast track here. If the fast track matches, and usually what you do with it is established and related connections, then it will spoil your IPSec. So the key is to put those accept rules in the firewall which match IPSec traffic before the fast track. So that's mandatory here, not to get into a trouble. Here is a small challenge for more experienced guys. In your IP firewall input, you have just a single rule to drop anything new. If you have 2 such MikroTik routers where IPSec is configured, can you establish peering? On the first moment, it feels no, because it's batching and dropping anything new. But if you remember that IPSec with default settings, both sides start to initiate connection simultaneously. First of all, there is an IKE protocol which has to bypass the firewall. Second, there is ESP. And if the connection tracking with the correct port numbers will see the connection from both sides simultaneously, and if the source port also is UDP 500 from both sides, it's established already after you have received the first packet. So be careful here with also the dropping new connections. A few words about troubleshooting. I already showed the phase 1, phase 2 setups. So within phase 1, you want to see established connection, and also within phase 2. If you have phase 1 ready, but phase 2 is not coming up, it's already halfway done. So what you do is you go and check IPSec proposals, which has to deal with the encryption settings. Otherwise, you deal with peer settings. So if remote peers are not here, you look for peer settings and firewall. If they are, you go to proposals. Finally, if you have also under the installed security associations, visible associations with the authentication and encryption parameters, in this situation, if still the traffic is not going, you look on routing and NAT. The most common mistake is that the NAT does the masquerade, as the previous speaker Jan showed, and IPSec is not matching the policy. So actually the security association is up, the traffic is not flowing. Another insight, what happens with the packet if the packet is too large. So you can consider L2TP and IPSec overheads around of 100 bytes. If the packet is too large, then after encryption, it cannot fit in 1500 standard MTU sizes. By the way, I have maybe asked you in different conversations why exactly 1500 MTU byte value is in the internet. Scientifically, that's the most efficient data rate for data transmission for 10 megabit Ethernet interface. So that's why, as we love 10 megabit interfaces. But anyway, we need to stick with the interface, and then we split the packet, so fragmentation occurs. What's bad, that each now packet has its overhead. If before that we had just for one packet, now it's for both. Also for those hardware measurements, what Jan said and MikroTik announces, MikroTik tries to do the measurements to get the best possible result. Not with all everyday situations you will get it, but here the point is when possible, to shrink the maximum segment size for TCP packets to avoid fragmentation in the beginning. So if you know you need 100 bytes, you can shrink the MSS by 100 bytes. So, and keep in mind that the key size also is influencing the size of the encrypted packet. So we have 10 more minutes to go. I would like to introduce with the IKE2 setup. Maybe we won't manage to do it during the presentation, but at least the first part and the second part you can add after. So this one is more difficult because here the certificates come in. So what's wrong with the certificates? First thing is that you need to create them or buy them, depends which approach you like better. The second thing is you need somehow to get them into your mobile device. In my experience, two easiest ways how to get them in. First one, to send them over email and then install. The second approach, put them on some web server and then download via the web browser. So two approaches exist. Here are two certificates. The first one is considered to be as a certificate authority. This one serves to convince your phone that the remote certificate is valid. The second one is a combination. It's encrypted combination where you have public key, private key, and also CA included. But as the mobile phones, at least iPhones for sure, do not accept it from P12 format, you need to do both. So here you can grab both certificates. If you open in your web browser, mom.tt.lv, you will see a list of two files. The first one installs without asking this encryption password, but will ask you a PIN code of your device. So if you don't remember your PIN code, then it's the right time to remember it. And the other one will ask a password with which the certificate is encrypted. So the password is from 1 to 8. All digits from 1 to 8 are here. So that's the first side of the configuration. When you have the certificate installed, then on your client device, the second part is almost as easy as on L2TP setups. You need to specify here the server. This was also previously. Then you need to specify a remote ID. This one has to match the server's common name in the server's certificate, or alternative subject name. Usually you do a match with the common name. Then the question is about user authentication. If you don't want extensible authentication protocol AAP, you say none here. Otherwise, you will end up spending a week and searching where's the problem, and it's not coming up. So it has to be none here. Then you specify that you use certificate, and now if we compare with L2TP, there we had passwords and usernames. Here the certificate serves both for the username and the password simultaneously. So when you have imported the certificates and configured the client side, the expected result here is just when you do connection to get status connected of IKE2. So here were the parameters. The server was VPN tt.lv and certificate for authentication. and to grab the certificates, it was mum-TTLV. So now I will look a bit back on the RouterOS configuration to see how much you need to modify now from L2TP configuration to come to IKE2. So switching back my screen. So we can use still the same pool. The same pool can be used. We will need now new settings in IPSec policy. So at the moment for the peer policy, it's said that the exchange mode is main L2TP. We could bring up also in parallel the second approach based on router ID, but now to keep it more simple, I will switch off the quickset and to show you how it's configured from the scratch. So no peers anymore. So I make a new peer where authentication method is now IKE2. Exchange mode is IKE2. Authentication method is RSA signature. And here I should specify the certificate. I have some certificates here in my files, but if I wanted to generate new ones, this is done here under System Certificates. Usually we start with a new certificate authority, and after that sign the users. If I do that, it will not match anymore the certificate which you download from the website. So I will try to import the certificate which is signed by the same CA. I have one here, and the password is 128, and I do import, and it had both CA file, which I could generate also locally, and the key file together with public key. So only here it's with a common name android.tt.lv. Yours was to VPN tt.lv and mum.tt.lv. So that's the certificate side. Either you import them or you create them. Then for the peer, we go with IKE2. We say RSA signature. We select the certificate which should match the first one. System certificates. The first one, yes, should be. Then for advanced settings, here's interesting thing, mode configuration, which will glue together your address pool with this particular peer. So before you can select it, you create it under mode configuration. You say, this is the VPN address pool. We provide also system DNS. If you want, you can override also it with some static DNS assignments, which will be assigned to your VPN users. So I say, OK, I have created it here. Now I can link it as mode configuration here. As you see, much more steps than it was for L2TP IPSec, where you just click one checkbox and enter the password. Then for generate policy, usually we do it port strict. And where is my ID, we will tell it that we are vpn.ttlv. This one has to match what you have in the remote server setting. So I could take it from certificate, I could override it also here. So if I override, that's it for now. So this is a passive speaker, and serves for IKE1 or IKE2 for phase 1 configuration. That's the phase 1 part. Also, we need a policy which will generate IP pools. I take just the pool address, which will generate security associations for each connected customer. So I say, if we have customers from this subnet 192.168.89.0, which connect, sorry, this one has to be zeros, in General tab, which connect everywhere. We want to generate a unique security association for all of you. So I say OK. Someone already tried to connect. I throw him out. Well, the remote peer is connected. 2 peers already coming in, trying to negotiate. And for installed keys, we see one of them already registered now with IKE2 already. As you see, this one required more effort as we had to deal with certificates. This is one area. And the second one to configure peer, policy, and also mode configuration. So expected result here is that you have installed associations. So 2 associations for each of your connections. I will leave this server open. If you want to do this challenge during this day, then here it is. So switching back to where we were in the slides. So we discussed the configuration and the expected result that IKE2 is connected. We have last 5 minutes. Here some emphasis on hardware. At the moment, regarding those boxes you can get from the factory, these 4 has hardware acceleration. With router board 850, it's a bit tricky because it applies only for those models where serial number starts with a digit 5. So if you have some in your infrastructure, you can look. If it's not starting with 5, advice is to sell it in eBay and get a new one. Main benefits from IKE2. First of all, the connection is established in 4 and not anymore 7 or 8 packets. Also, in 2 last packets, the security association is created. Also, now it protects you from passive attackers. So it's more light, more quick, and not friendly. If you want to go deeper in cryptography, here you could see how, and these are 2 popular Latvian names, Liga and Jānis, would exchange the encryption key. The encryption key was what you saw in security associations over the public cloud using pre-shared either certificates or the password. So these are mathematical actions, and in 4 messages, they have negotiated on the key which is used for them to encrypt the real messages that travel through the network. Finally, if you want to go more advanced, here are 4 ways to go. So first of all, with certificates, you can dig deeper and think of centralized authentication via the radius or smart cards. I will have a slide about that later, or secure certificate enrollment protocol. As we measured with L2TP IPSec, it happened quite fast. I would say within 1 minute, if you know what to do, you can do it easily. Imagine if you had, for example, if you worked for internet, for the bank, and you had in your infrastructure around 5,000 now ATMs where you want to install MikroTik routers. So then you need much more time. So this security enrollment protocol serves for automatic distribution of those certificates. For certificate, there is one tricky thing. It's limited within some time frame. If you generate them, also be careful in which time zones are your users. I have had cases in my experience. I generate a certificate, everything looks fine, but users complain they cannot come in. This is because they are in different time zones, and for them, the starting time is yet to come. So they are not yet in the right time. If you generate, you can select that it's valid from yesterday, then you cover all the time zones, what's here. And also for the certificate, it ends up at certain date, either after a year or 3. So if they pay you 4 hours, you have a new job to renew the certificates. You can just shrink the amount of the validity, and then you have more job. Regarding the certificates, what you need to remember that in MikroTik router, you can create them, import them, and export them. If you export, now there is a feature you can do it also in PKCS 12 format, but this is only in console. It's a new feature appeared recently. Here's an example how it looks when you create a certificate, and also if you want to authenticate the certificate over the Radius server. Then you specify the method to the exchange mode EK2 EAP Radius, and in Radius you specify the Radius server. It could be, for example, Microsoft Policy Server, which authenticates now users centralizedly from Active Directory. Finally, if you are lucky and have either router board CCR 1072 or CCR 1009 devices, these two have smart card slots. On those smart card slots, you can store CA, Certificate Authority keys. The problem is that these smart cards, which are supported, are not that easily to buy. So when you search for some, here is the key for what to search. They should support Java with specific version 2.1.1. If you have them, then you can place the CA on the card, and at the moment these cards are not hot swap, but even with some scripts you could make that the tunnels work when you have a card. And if it's a disaster situation, okay, with the big card it's difficult, but with the small card you could even eat it together with a lunch. And for sure, I don't suggest you eating the card, but more focusing on lunch as my presentation is over. So thank you. If you have some questions, I'm still here to take them. Otherwise, see you in MAM. Thank you.
Thank you, Andis. Andis, you're right on time. 12, lunchtime. And you know what you get for being on time? A gift.
That's good. Thank you.
Andis gets a gift. Do you know what's inside?
Something heavy, but have no clue.
It's actually a very nice thing. I showed you this device in the presentation.
Wow.
So it means it's very new.
It sounds even better. Can I open it?
Yes.
So
I think it's difficult to open. I'll just tell you guys, it's the 1100AH X4 with these hard drives and SSDs and everything.
My birthday is in June, but I start celebrating it today. Thank you.
Yeah. Our first presenter, Lorenzo, he was not on time. Just kidding. Lorenzo, are you here? You can also get one. Oh, well, I'll keep it. So, guys, now it's lunchtime. Until 1:30, you can do whatever you like. If you have the small cardboard ticket, you can get lunch one floor down. Just go downstairs. If you do not have this ticket, there's a supermarket like 100 meters from here. It has all kinds of restaurants. It's much cheaper, and you will get to stretch your legs. So be back at before 1:30. At 1:30 we start again with our next presentation. Also, you can now go and bother all the MikroTik guys who have all the new switches. Go outside to the exhibit hall. First of all, you can meet some nice girls in there. And then you can, on the way. And when you're done, you can go and ask those switch guys all the tough questions.